Hello, everybody, and welcome to the Crypto Hipster Podcast. This is your host, Jamil Hassan, the Crypto Hipster, where I interview founders, entrepreneurs, executives, thought leaders, artists, you name it, all across the world of crypto and blockchain, all around the world. And today I have, you guessed it, another amazing guest. All my guests are amazing, so I'm looking forward to it. Today, I have the CEO and co-founder of Aethos, Nikhil Raghuveera. Nikhil, welcome to the show.
Thanks so much for having me, Jamil. Great to be here.
You're very welcome. You're very welcome. So let me ask you first, what is your background, and is it a logical background for what you're doing now?
Yeah, it's a good opening question. So for context, before co-founding Aethos, I was head of strategy and innovation at the Celo Foundation and supported the development of the Celo blockchain and led a lot of the major Web3 launches on the Celo blockchain and really supported the ecosystem across a number of different verticals. So I've been in crypto for some time. And then separate from that, have also been pretty active in the policy space as a senior fellow at the Atlantic Council, which is a DC-based think tank. So have kind of tackled crypto both from as a builder, as an operator, as well as from the policy landscape, which informs a lot of how I think about Aethos today. And then started my career over a decade ago now in economic consulting in the litigation space on securities and antitrust, and then also spent time in management consulting where I focused on public sector, private equity, and pricing strategy. All these things are kind of great opportunities to incorporate those experiences into what we're really building is a completely new market of crypto at the end of the day.
I remember Celo being in this Ethereum report, a few years ago, an up and coming wonderful project. So I was wondering, it's always good to put a face to a name. So thank you for joining me. I want to talk about Aethos. What's it all about, and how do you enable the enforcement of customizable rules for on-chain transactions?
Yep. So Aethos is fundamentally what we call it is a programmable policy layer. Now, what does that really mean? It's something that is designed that allows for any developer project ecosystem to be able to set custom pre-transaction rules and logic for their smart contracts, for their sequencers, for L2s, for their solver networks, really anything that is on-chain. And those rules and conditions are, what we call them policies. And those policies can incorporate any type of historical on-chain information or off-chain information. And really, you're using that type of information to define some type of pre-transaction rule. And what Aethos essentially does is it functions as a pre-transaction compute. It's really doing this kind of check before a transaction comes through, because you're setting some type of rule. That's fundamentally what Aethos is being built for. And our view is that as this industry evolves and continues to mature, you're having more and more complexity that's happening on chain. You're incorporating more and more conditions, and we're trying to really kind of simplify that experience. And how can you build a system in which you're incorporating all this different arbitrary information that's happening around the world? And how do you incorporate that in a way that can be used for a specific logic that you want that's done in a pre-transaction fashion? That's high level what we're doing. There's a number of different use cases that this can be used for. But I'll pause there first because I'm happy to kind of dive into any of those specifics because that's relatively abstract to start.
I need to, I speak to people in the accounting circles, right? And their challenge to me is, what do you do about blockchain auditing, right? And you're saying that you're doing the auditing, or you're doing everything pre-transaction, right? What are the benefits of it?
Yeah, so at the end of the day, when you're doing something pre-transaction, I think the first part here is, if you think of any traditional Web 2 company, right? If you're going to go and interact with a consumer Web 2 application or really anything like that, it could be, an Uber, Netflix, Airbnb, PayPal, any of those things. When you go and interact with those applications, there is some type of pre-transaction logic that's happening. For example, for Uber, you can't really envision a world in which you get into a car and have no idea if your driver is someone who's going to take you to really where you need to go at the end of the day, right? That's a pre-transaction logic that's happening. In the case of Airbnb, if you're an Airbnb host and you're going to have someone you've never met before in your life stay at your place. And you have some belief that they have not torn apart a place that they've previously stayed at when they interact with you. And when they're like, oh, we're going to send over this money so we can stay at your place, and you're going to give them access. All of those things, there's some amount of logic that's being built in to their platform. Netflix is another really interesting example where I met the guy back in 2011 who has one of the patents for what Netflix uses for geolocation. And for Netflix, geolocation was really important because they were able to, as a result, create custom curated content for viewers all around the world and have the media partnerships for that. And so, if I'm in the US, I can watch certain things. If I'm in India, I can watch different things. And that's all that we see it as a pre-transaction logic. And then maybe the most salient for anyone in crypto is what PayPal did. PayPal spent a lot of time and energy building really a policy engine at the end of the day. And the reason is they were really worried that you'd have a lot of scammers who use PayPal. And that, if when we go on PayPal and then we're interacting, that there's a huge risk that we're going to be interacting with a scammer on the other side. And if they didn't do that, PayPal would feel a lot like crypto today. So all these kind of Web2 companies built some type of pre-transaction logic for how one interacts on their platform. But in that same vein, as you're looking in Web3, you're building, infrastructure, you're building consumer applications, you're building DeFi applications, all these different things. You're going to need to have pre-transaction logic to deal with all these different kind of complexity. And that's really what we see Aethos as. It's creating the generalizable infrastructure for any builder to be able to create and implement and enforce pre-transaction conditions for whatever they're building.
Sounds good. I want to ask you about your actively validated service first, and then I'll dive a little bit more into the policy. What is actively validated service and how does it work?
Yeah, so an actively validated service is what we basically are building on EigenLayer. And so an actively validated service, or an AVS for short, utilizes the shared security of Ethereum and ETH in order to provide, essentially function as cryptoeconomic security for whatever you're building. So we're an AVS on EigenLayer. There's a number of other AVSs who use the shared security that is offered by EigenLayer to be able to bootstrap their cryptoeconomic security. So for us, why does it actually matter? Why do we need cryptoeconomic security for what we're doing? So let's say you're a builder and you put in place some type of pre-transaction rule. You need that rule enforced, right? If the rule isn't enforced, it's not really a rule at the end of the day. Now you have to trust someone to enforce that rule because you're pulling, let's say, some type of off-chain information, also incorporating some on-chain information. And you need someone to actually go and do that work for you. And in our case, we have a network of off-chain operators, traditional operators, very similar to, a blockchain or any type of Cosmos SDK, or even any of those kinds of operators. And there's a number of operators who support EigenLayer. And so they're responsible for actually doing that compute. So in our case, an application integrates Aethos and they define that rule. That rule is stored, that script is stored on Ethereum that tells the operators what to do for that specific smart contract. The operators then, in this case, when a transaction is coming in, they're responsible for checking if the transaction adheres to the policy. The operators are the ones who are responsible for checking. If the risk here is that if you have, let's say, no incentive for the operator to behave good, they could behave maliciously. And a malicious operator could say, you know what, we don't really care what the rule is, the policy that you've set, we want to enforce our own policy, which means that they're able to even potentially censor the application. That's a huge risk, right? Because now you have the ability for an external operator to literally censor the application because you're saying, we're going to enforce whatever rule we want. We can't allow that to happen. And so that's why we use cryptoeconomic security. If an operator behaves maliciously and says, we're not going to enforce the actual policy that's been issued, their ETH is slashed. So they have staked ETH, and that is a slashing condition. So in this case, what we're using EigenLayer as an AVS is ensuring and creating a trust minimized system such that the operators are incentivized to actually support that policy and not behave maliciously. It's really important because we're trying to create a trust minimized system for policy enforcement. And you can, draw parallels in traditional world, right? It's like it would not having cryptoeconomic security and having a world in which an operator can do whatever they want would really kind of be a system in which let's say you have any type of arbitrary rule. Let's say you go to a restaurant, right? And the rule in the restaurant is this could be a really innocuous one, but you have to have shoes, right? No shoes, no service. Presumably that rule needs to be enforced. If it's not enforced, then then that rule doesn't exist at all for that restaurant. And so in the same case here, for what we're building is that you want to make sure that those rules are enforced. That's the only way that a rule is actually true. That's the only way a policy is actually true. And so that's why we use EigenLayer as an AVS, is to ensure and have a trust minimized mechanism for all of this.
And you have to incentivize the validators. So
that's right. Or alternatively, the application could just trust that the operators will behave in the way that they should. But as an AVS, you have cryptoeconomic security so that if they behave maliciously, there is actually an economic cost to that. Otherwise, you can say, you know what, you don't need any economic stake. We're totally fine with it. And maybe some applications will be okay with it. But that is a huge amount of trust you're putting on operators, saying that we know you won't change your mind. We know you won't behave maliciously. And so that is a trust assumption. So we're trying to get rid of that trust assumption and have something that's more trust minimized. In this case, it's having them secured via ETH. And so if they behave maliciously, then of course their ETH is slashed. So they're incentivized to not behave maliciously.
Got it. Makes sense. So you said it a little bit earlier, you have a generalizable policy engine, right? Why is a generalizable policy engine necessary, and how does it empower pre-transaction policies as opposed to having, I guess, specific engines for each policy?
Yeah. The way we see the world is that blockchains, one, will be a global financial settlement system. That's really the end goal, right? For blockchains and Web3 and crypto, as you transition from the traditional financial system. But then the second piece there is that blockchain networks are cities at the end of the day. That's how we kind of see the world, is that you're building cities. The blockchain itself, an Ethereum blockchain is your core infrastructure. That is the foundation upon which a city is built. And then different applications or different types of stores. You have, other infrastructure such as cross-chain messaging, which connects one city to another city. They were building these cities that people are participating in. And so in that world, when you have a city, you have, certain rules and conditions for how one even interacts or moves around. And those vary, and, rules can differ based off of different settings, right? So, if you're trying to go to a restaurant, they might have a dress code. If you're crossing the street, you're going to have, you have crosswalks, right? Because you want to make sure you don't get hit by a car on the way. If you have a railroad, you have, gates that come down to make sure that a car doesn't go through the same time that the train is passing. Of course, you also have police stations, you have fire stations, you have all these types of things that are really, at the end of the day, logic that's embedded in society, so like the broader society of that city. And they vary in different settings. There's some that are, of course, defined by a city government, by a state government, a federal government. Others are more social norms. All of those kind of determine how we kind of think of communal associations. And I think this gets really philosophical, is that that's really the way humanity even operates. This is kind of that broader piece. So then kind of going into, okay, great. So why does Aethos matter in this case? Which is really what you're asking. And why have something generalizable? It's because otherwise, every single application, every single group will have to build their own custom logic from scratch and maintain it. It can be a really big lift. And they're doing things that are not necessarily part of their core logic at the end of the day. If you take a restaurant, their core logic is, having a restaurant, cooking food, providing a meal. It's not some of these other things. You don't they're not necessarily there to enforce every type of rule. That's not their core business. Their core business is having really good food. And so in this case, we're saying the great part in Web3 is that unlike Web2, in Web2, everyone has to build usually their own systems for a policy engine, those rules and conditions manually themselves, and maintain it. But in Web3, you're able to use building blocks. And that way, what you can build here is a more generalizable, programmable version that is trust minimized. So everyone can use this infrastructure to specifically build the rules and conditions, make that entire process easier. and one that they can say, look, like it doesn't undermine our security, it doesn't undermine our decentralization, and it lets us not spend as much time building all these things out and maintaining it. That's how we kind of see the world and where Aethos fits in the longer term.
I like it. I like the city analogy, and I like the philosophy. It sounds good to me. You know, you believe that smart contracts need to continue to evolve, right? And a lot of people don't even know what a smart contract is, but some of us do. You know, how can cross-chain data influence the evolution and the build out of smart contracts? What are your thoughts on that?
Yeah, I mean, I would say both cross-chain historical blockchain as well as off-chain data can all make smart contracts even more effective. At the end of the day, a smart contract is some type of code that's designed to execute a specific action for a blockchain-based system, right? And that's what we interact with if we want to do whatever type of thing, whether that is bridging an asset, swapping funds on a decentralized exchange, going into a borrowing and lending protocol, any of those types of things. But smart contracts, you're limited in the compute capabilities of the blockchain itself, which isn't that high. And so in order to be able to do that, if we're trying to create more and more complex actions on chain, you need to be able to incorporate additional information. And that information can be things that might be across chains. So an example is a reputation type of system. You know, we've talked a lot about recently, like Sybil resistance, and in the case of token airdrops, and is it bots who are farming your application, or is it a real user? And that type of information is things that you can figure out across chains as well as off chain. And that type of information is really important for when one is interacting with a smart contract. Or in the same case, if you're trying to create an access control for who can even participate in a system, because you're saying that, you know, it's a higher yield vault, for example. And for you to access this higher yield vault, you need to have done all these other things before. You can't just come in and I get access to this higher yield vault. And all of that is incorporating. It can incorporate off-chain information or even information across other chains. Another use case that we found to be quite important is particularly for real-world asset projects that are that have identity solutions that are involved, usually KYC type of solutions. For them, you know, I might have a KYC or an identity or an attestation on one L2, but I might also, but that RWA project might be on another L2 or on another chain entirely. And so if my identity is on one chain, how can I use that to be able to access this RWA project on another? That's a case of how do you have that information go from one chain to another? And those are the kinds of things where we see a world of, if you're going to have thousands of L2s as well as many different, you know, cities and smaller towns, your information in one city or town should not be limited only to that one place, but you have a broader existence that based off of the actions that you've taken in other places that you've visited. And so those should all be able to be incorporated in a smart contract system. And that's where those kinds of things are very difficult to just do at a base smart contract level.
So you see the world as multi-chain.
That's right.
There are a lot of people who will argue with you on that. I don't know why, but they would. You know, why should the future be multi-chain instead of maximalist?
So my view is that you'll have a few core chains that are kind of your base L1s, let's say. But I think in the world of you'll have more L2s over time. And the reason why you'll have more L2s over time is that foundationally, I mean, especially for something like Ethereum, it's too expensive, too slow to be able to have everything solely on Ethereum. You'll need L2s to really make that work. And L2s can vary and have different purposes and different types of ecosystems on them. You're creating communities within a broader, you're almost creating like different segments within a bigger city. And that's human nature, right? Like we've always created smaller communities within a broader community because that we live and exist off of our communal associations. And in the same case for L2s, from a technology standpoint, different L2s have different capabilities and functionality. In the same case, you'll start kind of also seeing layer 3s that are dApp specific. And really, at the end of the day, the reason for this is the customizability you're able to get for different L2s. So you'll have some that might be more general purpose L2s, others that might be more dApp specific, application specific, use case specific. it's having the tooling in there for all those types of pieces. And that's important because it keeps fee costs low. You're able to have customizability in terms of the speed of execution. You're able to have different types of trust assumptions, which is really important for different applications and what they're doing. So yeah, I believe that you'll have a lot of different L2s as this industry evolves. Of course, the important thing here is making sure that these L2s are not fragmented, right, across one another. That is still a big challenge, but I know that, I mean, there's a lot of folks who are working on really addressing that. Optimism has, their superchain thesis. Polygon has been working on their EigenLayer. You have a number of groups that have all been working through this, and I think that gets solved over time. But the expressivity for a blockchain for an L1 can't all happen on the L1. You're going to need L2s to be able to basically make all of that work. Now, that being said, you'll probably have a few L1s that are the core L1s for all of this.
Yeah, I agree. So the whole thing is to bring data, more data, better data, and there are some methods. There are the new methods, and there are the old school traditional methods, right? What remains some of the limitations and challenges with incorporating traditional methods of data, across applications through organizations, and how we solve them?
Yeah. So far, we've seen the way of bringing data is usually through Oracle networks. So you have a lot of those, right? And that's kind of V1 of bringing data from off-chain, particularly to on-chain. The way we see it is that oracles were the first step, but for what we're building for a policy layer, you also need this compute component that has to happen. And that's where we function as off-chain compute. And so in our case, for what Aethos is doing is you define a policy which may involve some off-chain information. And let's make this even more tangible, right? Like, because I realize that this has been a bit more abstract. I think let's say like one use case is on preventing money laundering, AML. You might be an application, let's say particularly one that's focusing in the real world asset space, or a use case in which you're saying, hey, we're really moving money here, and our users have concerns that their assets are going to be commingled with a sanctioned entity. Huge problem in traditional finance. It's also a problem in crypto as well. What we have here is you're using off-chain information, which is a sanctions list that are published by various government entities, for example. So you have those sanction lists. Those are static lists. But what you also need to think about is a flow of funds, because if I'm a sanctioned entity, I'm immediately going to hop my funds from that address to another one to avoid being on that sanctions list. And the US government doesn't update their list real time. So in this case, you have an off-chain information, but you're also incorporating on-chain dynamic flow of fund information to say, wait, is this new address, is it still part of that sanctioned entity? What's the level of risk of that? So you're incorporating on-chain as well as off-chain information. And in this case, that's a type of compute because you're making a determination there. And then in our case, what Aethos does is our operators say, let's say an application puts in place a policy for AML, our operators say, you've defined certain parameters for what happens if this sanctioned entity on-chain moves funds from one address that's been flagged to another one. Should that new address be incorporated into what you guys see as basically a dynamic blacklist? The operators are going to run that computation and then say, hey, yes, based off of the policy you've set and the parameters you set for the growth criteria, this new address is also directly tied to that sanctioned entity. And so you don't want that one to also be, you want that one to be included in a blacklist. That's a compute. And the operators are making a decision and then issuing, in our case, basically a check, a signature saying that these addresses have, this is a dynamic blacklist of addresses and they're all associated to a sanctioned entity. So it's that type of computation that you're having that's incorporating off-chain information as well as dynamic flow of fund, real-time flow of fund information. That's kind of the world that you have over time of that complexity of you're incorporating that off-chain information. And so far we've had just the off-chain information being brought on, but then you need to be able to do additional you have to be able to do more with it. And that's where we're going.
So for those politicians who say that crypto is only used for laundering money, what do you say to them? How effective has this been in the prevention of money laundering and laundering of sanctioned assets?
If something like Aethos is used for different applications, you're actually able to prevent that. is what we've able to show. You can show best effort of really being able to prevent it. Obviously, it's never 100%. 100% is very difficult, and so I'm not going to say that you can 100% stop all of it, but you can actually stop it to a meaningful level for different applications. Again, we would say that this should never be incorporated really on a true layer. Like, it shouldn't be used at a layer 1 because layer 1 blockchain should be credibly neutral. And there's a number of things that should be credibly neutral. But in our case, different applications that need it because of what they're building can of course incorporate Aethos to have an AML type of policy.
Sounds good. It doesn't sound abstract. It sounds like a real use case, so that's great. I do want to talk about a couple other use cases. First one is decentralized finance, right? And basically, a lot of the things now are moving towards community-based things. So how do you foster community-aligned liquidity in DeFi?
Yeah. Community-aligned liquidity in DeFi is something that, again, this varies by kind of ecosystem and by the DeFi application in question. But we have some views of community-aligned liquidity already. The baseline is, if you're going to participate in something like Aave, there are certain assets you can deposit as collateral and a number of assets you can't. And that is something that's usually voted on that's voted on by governance, right? And you have groups that do risk analysis of those assets themselves and saying, what are the risks of these assets being used as collateral? What is the parameters that we can incorporate for this? All of those things. That is a view of community-aligned liquidity to start. But community-aligned liquidity can be more than that. And that's what we see for something like Aethos. And a big one that comes up every so often, almost like every week or every other week, is you have a major exploit, right? You have a major exploit, and those assets are going to be moved everywhere. The question is when you have a community, are they comfortable in receiving those assets into that ecosystem or not? And that's a very open question that no one has truly answered yet. And we're not always thrilled about it, right? That you have an exploit. So I think a good example here would be take like what happened on Blast, for Munchables. Thankfully it all worked out, but you had what looked like it was going to be a very major exploit. And the only real solution here was for Blast as an L2 to just roll back the chain and just say, you know what, this was never really done, which is one option. Probably not the ideal option. But the other thing that Blast as an ecosystem could do is they could say, hey, look, the different Blast applications could say, you know what, we don't want to accept these funds. We as an ecosystem for these different apps will actually pass a governance vote and say, these assets were stolen from another project, like we're not going to take them. So you can't actually deposit them. That's an example of community-aligned liquidity. And it could even, when we go to a world of L2s and you start having, this is why having like a world of L2s is very interesting. Because L2s themselves could, as they decentralize, actually say, in some cases, we don't even want the movement of these funds. Give us this money back because you've stolen it, that from a core infrastructure piece in the L2, this was not okay. Or you can alternately have it blocked from leaving bridges. And so that's when we think of community-aligned liquidity is we are creating these communities for applications, and you're going to have a universe of different types of groups that are some fully permissionless and open that anyone can deposit and move funds through. But then as you have more and more like types of L2s, as well as even hooks, take like a Uniswap v4 hook world, you're having this type of more customization and specificity for all of these different parts of the stack. And that's what happens in community-aligned liquidity is the evolution of that. I think another really good example of this is even community currencies. And I know they haven't picked up heavily, but they can be quite large. And I know different folks have worked on them. That's community-aligned liquidity because not everyone can go and pick up a community currency that's defined for that community. I, as someone who's in San Francisco, can't go and get the community currency for a project that's located in a community in Kenya, for example. That's not possible. That's community-aligned liquidity. And if you're trying to create more and more models of community-aligned liquidity, you need the tooling to actually be able to do that.
So you're not talking about online community, you're talking about actually real community.
Yeah, that's right. It could be real communities, it could be online communities, but the full mix. But over time, of course, we're merging our online and our physical selves, and that's happening more and more. And I think in the same way, that line becomes less and less clear. But yeah, that's right.
Got it. Sounds good. Another area. So we're talking about currency, talking about money. Let's talk about content, right? One of your use cases is to help with gated content in gaming, right? How does unlocking gated content or enabling unlocks occur, and how do you help out with that?
So this is a use case that we're probably earlier on. We haven't dove as heavily into it. So I will say that and caveat it. But what we're able to do is for a gaming project, especially a fully on-chain game, you're determining how one can participate in that game, right? And so you have both in-game logic as well as hypothetically, let's say you want to go and unlock a new world or unlock a new item, or even you might even care about Sybil resistance for whatever you're doing. For all of those types of things, you have to incorporate on-chain information that's been done, right? So some type of on-chain actions, on-chain transactions, or even actions that have happened on other chains, going back earlier to the Sybil resistance question. You're doing all those kinds of things. And so in this case, what we're able to do is a gaming project could use Aethos to set that pre-transaction rule, and they define, great, so if someone is going to interact with these contracts, either for a Sybil resistance or to unlock this new item, whatever that is, they need to have done certain things. And so you can set those growth parameters, define what that is without having to go and build all that logic yourself. And that's where something like Aethos is able to come in and essentially support that type of infrastructure from in a gaming world.
Got it. Civil resistance. You said it a few times, so I got to touch on it. 4 years ago we had elections in the U.S., and this year we have elections in 30 countries. And this year the market cap crypto is not quite where I think it should be, which is much higher, right? What role do you think we'll see civil resistance or maybe even civil unrest having for the remainder of the year, and how do you see that, impacting the crypto market and your role in it?
Yeah. So it's kind of like there's kind of two parts here. One is, so civil resistance is thinking about bots and how do you ensure that someone who's interacting, of course, is a real person for that contract. That's going to be more and more difficult, and it's going to be more and more important to solve. And I don't know if anyone's truly solved this yet, but as you're having, there's been this ongoing question, I would say, of in the world of blockchains and L2s, as you talked about multi-chain world and all the different applications, how much of the usage is done by real people versus how much of it is actually executed by automated bots. And that's kind of this merge of crypto and AI. Still a very ongoing question. I don't think we're not going to answer that on this call, on this episode, but something that we should definitely keep a lookout for. And that's where something like civil resistance really matters, is what is real and what isn't. And that's always a question when you're merging the physical and the virtual. And then if we think of kind of more generally, like anything you're also asking around like civil unrest more generally, and what that might mean in a blockchain system, I think in my mind, that's kind of this bigger question of what is a trust that we have in institutions, right? Traditional government institutions, as well as trust in financial systems themselves. And that's where blockchains are quite powerful, is that they are designed to be trust minimized. And so, things such as like hyperinflation in a country, like instead of using the local currency, you might want to switch to a more stable asset. And we see that, or you might live in a place without strong financial infrastructure in the first place. And that's where, again, blockchain technology is quite powerful in that. The other part is, if you're a migrant, or if you're someone who is in a country that is experiencing civil unrest, and you have to leave that country, one of the things that we don't talk enough about is actually that for refugees, how do they still have access to whatever funds that they had before? How do they have ownership over that? That's something that blockchains are very uniquely situated to be able to do. And so over time, you're seeing this fragmentation of the world, and a question around what do you trust and what don't you trust? And the ability to trust in a decentralized technology can actually be quite powerful, because there's no central parties who are responsible for governing, the ownership of those funds themselves. And that matters a lot. And that's kind of where I see the world going. If you have more civil unrest, it does mean that blockchains become more and more important. And it's on us to really make sure that we build them appropriately to be able to meet that need.
Makes a lot of sense to me. Got it. Thank you. Um, I want to thank you very much for your time today. I really enjoyed speaking with you. Um, yeah, and I have one last question. It's an easy one. How can people find out more information about you, about Aethos, about what you do? How can they be part of the protocol and solution?
Yeah, I would say they can follow us on Twitter, or check out our website, aethos.network. Our Twitter handle, I believe, is it's at Aethos Network, AETHOS Network, all one word. Uh, Otherwise, feel free to also you're also happy to feel free to reach out to me directly on Twitter. That's also pretty straightforward. And then my Twitter handle is at Pumper Nikhil, so PUMPERNIKHIL, all one word.
I like that. Thank you very much for your time today.
Definitely. Thank you. Great being here.